Wow, full room. Thank you for coming, everybody. I think a lot of people here, especially people who've worked in operations or in engineering for some period of time, will appreciate the world that we're in now, where you don't have to pester operations teams constantly to spin up new hardware or build infrastructures for you. We're in a better place now, I think, where there are more options available to us, to engineering organizations as a whole. But a lot of those come with challenges, and there's new ways of thinking that need to be adopted. And we have Yavor here from the BBC, who's going to talk to us about some of the ways that they've been dealing with these things and some of the infrastructures that they've set up. Please give it up.
Hello, hey guys, you hear me? I think so. Yes, okay. So today we'll speak about machine is dead, long live the machine, which is a fancy way of telling you pretty much nothing. The actual talk is about service resilience and deployment automation at the BBC, and that's the British Broadcasting Corporation, not the Barcelona one. So today we'll speak about the deployment pipeline that we've developed, the different services that involve that. We'll speak about building software, building virtual machines, provisioning infrastructure, cloud architecture in general, and kind of how that fits in together. So my name is Yavor Atanasov. For those of you that read Bulgarian or Cyrillic in general, that's how you write it as well. And I'll be speaking with you as a software engineer today. I was built in Bulgaria in a very irreproducible way, and I'm currently deployed in the UK, London, where I work for the BBC. Good, because that's the only joke you're getting. It's all dead serious from now. Right, so without further ado, the BBC, turns out, it's a big organization, but the thing that I kind of learned when I looked into this, and it surprised me, was not just the depth of audiences that we have, but the breadth of services that we cover for that. So we're the 5th largest site in the UK and the 55th globally, but we're also top 20 for quite a wide range of things, including news, sport, arts, and children's content. And what that means is there are quite diverse set of teams at the BBC doing quite different things. My team helps other people deliver software fast and reliably. And that's for now and also in the long term. And there's a subtle difference between the two, because people that care about now, like you as a developer, you want to be able to focus on the speed. You want to deploy fast. You want to push your updates fast so you can test them, or you want to roll back fast in case there's a problem. But then there's also preserving that in the long term, which is important maybe for you as well, but most probably for the organization around you. They want to be able to have that history of builds. They want to be able to reproduce that even when you leave. So my team provides tools that are used for building and deploying services, mostly on AWS at the moment. So today we're going to speak a little bit about where we were before. Then I'm going to give you a high-level overview of where are we now, just to give you a kind of frame of reference that you'll be able to come back to as I'm zooming into the details. And then we're going to meander through the different principles that we've gained along the way and how we actually got where we are now. And then, obviously, we're going to look at what does this all mean, because technology means something. It's not just, a bit of a faff. Anyway, our previous platform, it was a shared physical hardware, a lot of services running on it, might be familiar to some of you. Strong separation of the operations and developers team. Developers deployed to test, operations touch live, very strong separation. And because it's a shared tenancy of services, you get a limited set of technologies. And what this means for people is that you get long release cycles, and that brings harder risk management and frustration, because you get a lot more into the releases, so there's bigger risks there. The separation of operations and devs it's a very social thing. It brings friction and alienation between people. And the limited set of technologies means that, we're forcing people to cut an apple with a chainsaw, because all we have is a chainsaw, even though you just want to cut an apple. What this means for services is there's a higher risk of breaking due to the updates, because they're longer cycles, a lot more goes into them. Slow resolutions of live issues purely because when there's a problem, you need to go through so many layers until you actually get to the person that, knows how to fix it. And there's a much wider impact area in case of a problem because of the, services sharing tendency. So if something goes wrong here, the service over here has problems. So we needed to change something. And the obvious things that we had to change was the better service isolation, faster, more continuous deployments, faster releases with less risks in them, easier infrastructure provisioning, and actually being able to give people the power to provision infrastructure themselves. It's a very powerful concept. No hard limit on technologies, so people can choose solving the problem with the most appropriate language for the problem. That's a very powerful thing. And then also mix a little bit developers and operations so they become friends or don't hate each other. So that was where we were, and we're going to have a quick look at where we are now. So currently services run in dedicated infrastructure. Teams can create that infrastructure. Teams control their deployment cycle so they can they have full control over when they push the test and how they promote to live things. They choose their technologies and they're responsible for their service. So they the first 4 items are what they gain, and obviously in return for that we would like them to be responsible for these things, and that's a good thing. So how is our deployment pipeline doing in terms of numbers? Well, currently we do a little bit more than 300 deployments per day, and for the first 18 months we've done 1,600 deployments, and that is more than the number of deployments that we did with the kind of Jira-driven approach in our shared infrastructure, where you raise a ticket and operations get involved, and operations are a limited resource, so you don't get that big of a throughput in terms of deployments. Time to life has gone from, that's time to life, not time to live, has gone from 2 days to 10 minutes. And teams that are currently using these tools in the BBC, that they're brand new tools, so that not all teams are using those, so they're gradually shifting to using those. We have the all key video encoding and transcoding packaging for BBC iPlayer, the pipeline for delivering election results to the BBC News website, live text for all BBC Sports events, and there's a lot more coming in. So let's quickly look at what the pipeline actually is, and then we're going to zoom in into the kind of meaty details of technical things. So that is the pipeline that we have. That's the path from developer's keyboard all the way to live audiences. It's nothing crazy. It's quite simple. I guess simple is good. The different systems that we have involved are version control. So we support both SVN and Git. Then we have CI, in this case it's Jenkins. We have a repository service that takes packages and exposes them as YAML repositories. We have our Cosmos service that is the central service that allows people to create services, provision infrastructure for them, and thus defining the environments for those services. And then it provides also the buttons for deploying to the different environments. We have a bakery service that produces AMIs for now. And kind of on the right side, you see a sample representation of a service. This is usually a collection of CloudFormation stacks and Amazon infrastructure in general. So very quickly going through this, developers commit, Jenkins pulls their updates, produces packages, pushes them to the repository service, and registers the release with Cosmos for that particular service. And then developers, either programmatically or by pushing a button, kick off a deployment in Cosmos. Cosmos uses the bakery, sends the metadata for the release, gets an AMI back. An AMI is a machine image, an Amazon machine image, and then updates their infrastructure with the new software. So we're going to take a little step back, and we're gonna build into this, and we're going to start with how you build your service. What are the building blocks of a service? Well, there are not that many. We have sources, packages, containers, and machine. And so this is the way in which you can actually combine them to produce a machine that has a running service in them. That's it, just 4. So I'm going to quickly run through them. we have a source built into a package installed on a machine. The other one is source built into a package and installed in a container that then gets deployed to a machine. We have a source put directly on the machine, so no packaging involved. And then sources put in a container without a package, and then the container is deployed on a machine. Those are the choices. I guess I'm quite interested in which ones do you recognize as the ones that you deploy, but I can talk to you about afterwards. What's wrong with these two? So they're the ones that don't involve any packages. Well, how do you express dependencies of your software without packaging? I have my software, a bunch of sources, but I depend on things. So how do I express that? And don't tell me bash scripts, because that's what packages are for. Use systems that are designed for managing dependencies. Don't invent them. Do it in a declarative way, whichever way you build your spec file, not an imperative way with a bash script. We're going to come back into this. So that leaves us with two options. Option B is very interesting. It's certainly dynamic in the recent 2-3 weeks. Containers. The containers are definitely a good thing, but the overall way of how you manage containers is an interesting space, and it still has to mature. So there are some questions there that need to be answered, which is, deployment and management tools. They're still immature. There are tools now that can actually deploy the instances, but how do you scale them? How does this scaling reflect your billing? Because you're still paying a fixed price for the underlying infrastructure. That is an interesting question. Managing dependencies between the things in the container and in the underlying host. That's the talking about fat versus thin containers, etc. Yes, and that's the billing thing. So vendors may need to think about billing based on container usage, because the idea for the cloud is for you to be able to scale your billing, and currently you're kind of paying a fixed cost for your infrastructure anyway. The point is, it's a dynamic topic, and we'll see how that develops. But for now, our service is a source built into a package installed on a machine. Now, why did I go through all this? Well, I did because this is kind of the logical way which will lead you to the set of binaries that you need to build as part of your deployment process. And so we need to build packages. Those are like RPMs, Debian packages, whatever you're using. And then machine images. And in the Amazon world, those are the AMIs. Now, when building binaries, there are some important principles that you have to follow. Namely, building binaries in a reproducible way, building them once, and then leaving dependency management for tools that are designed for that. So we'll start with building a package. Different level of package managers. Which one do we package for? You have this is a CentOS example. We have YAM, which is the OS-specific package manager, and on top of that you have the more portable, the more generic ones. Which one do I package my software for? Again, look at your dependencies. If all your dependencies are coming from one package manager, package for that. So if I want to depend on node modules, build an NPM package. But the moment you hit a lower level dependency, in order for you to have a fully kind of reproducible workflow and build an artifact that can express everything that it needs, you need to go down level, which means at build time, resolve all the higher level dependencies that you might have from pips, from NPM, whatever else, and then wrap that in an RPM. And by wrapping it, you express the operating system level dependencies for that. CI is critical as a process. Your choice of CI is completely irrelevant. Just choose whatever you don't hate looking at. The build itself needs to be done either in clean CH routes using the mock utility or within Docker containers. But the point is, you always do it in a clean and reproducible way within an environment that has the very minimum, making sure that you've always defined everything that you need, and the package that comes out of this has all that stated as dependencies. So as a quick example how we build packages, we use Jenkins. And we use the mock utility to build the RPMs in a clean CH routes. And yes, we build RPMs because we use CentOS for now. So the next step is we build a package. Let's look at the other binary. Let's build up into how we build a machine. Well, guess what? Building a machine is just like building software, right? build binaries in a reproducible way, build them once, and leave the dependency management to tools that are designed for this. Now, if you think about it, what's in a machine? A machine running a service. You have the base operating system, and then on top of that, you have your service with all its dependencies installed. And that is your software binary. This is the thing that will never or should never change across environments. The only thing that should change is the environment configuration for that service on top. So when we move machines from one environment to another, what we call promotion, is we do the minimal change, which is the configuration. I'm going to look into this into detail when we look at the bakery service that we have. Now, when we speak about building virtual machines, we really speak about baking. I guess that's the term that's kind of generally accepted. And when we bake machines, there are two extremes which you can go, which is a full bake or a bootstrap. A full bake is when at bake time, you install all the service dependencies and you put all the configuration, everything that the service needs, and you snapshot that and you create the MI for that. This means that at startup, you're just ready to go. You don't have any startup dependencies, nothing. And you've truly built your binaries once. Because with the other approach, the bootstrap, is when you have just a very thin base image, and when the machine starts up, then there's something that boots it up and pulls in all the software, all the configuration dynamically. But this way, imagine if you have hundreds of machines, and they're constantly dynamic. You scale up and down. This means that every time an instance starts, there's network dependencies there. Your service doesn't immediately start, so there's a bit of a slowness in your response. So the thing is, it's not these two options as kind of discrete options. It's a continuum. So where you position yourself is really down to you, down on your whatever your requirements are. Our approach doesn't, although it encourages you to do a full bake, and the easiest setup is you go full bake. You could move along that continuum if you like, but those are the things they need to take into account when you make a choice. Think about network dependencies, think about start time and reliability, and think about the building binaries once thing. That's important, because if you build about binaries once, only then you can guarantee that as your instances start up, you're not going to end up with different software, right? Because when your instances start up at different times, from your perspective, you're going to be running the same version of your service, but you'll be pulling a different dependency because some repository was updated. So this kind of pretty much invalidates your tests, or introduces risk anyway. So how we bake Amazon images in our case. Our bakery is a service that takes repositories information, the packages that you need to install, and then any environment-specific configuration. And then it returns an AMI. And there's a detail there that it does this in 2 steps. So it takes one snapshot just for the software, and then another one after applying the configuration. So this is familiar. We looked at this. When I make a request to bake an AMI, the bakery starts with a base snapshot that we kind of maintain asynchronously with just a minimal OS installation. It creates an EBS volume, it attaches it to the bakery, and then locks YAM into that and does the YAM installation of your service and all its dependencies. And then after that point, we take the first snapshot and we record that against that bake. And then we continue forward, we apply the configuration, and we snapshot again to produce the final snapshot, and from that we register the AMI. So usually people will do that when they deploy to their first environment, whether it's integration or test, and then they run their tests, and if all goes green, then they promote this to live, which is the same call. We're still baking, but we're not starting. We're not going from the same process from scratch. We're actually starting from the already recorded software snapshot, and we just apply the configuration. So we do the minimal change. Cool. So we spoke about packages, we spoke about machines. Now let's speak a little bit about provisioning infrastructure. The infrastructure is going to run our machine. Right. Here's the thing. Hardware is now software. Let's accept it. It's not exciting anymore. Let's actually use it as software. Let's treat it that way. And what that means is that we can apply the same principles we apply for building software and virtual machines. build binaries in a reproducible way, build them once, and leave the dependency management for systems that are designed for it. Now, when we speak about infrastructure provisioning, there's many ways you can provision infrastructure, obviously. You can open a console, click buttons, you can write a script that imperatively goes and does things. But there's power in actually being able to declare your infrastructure, define it declaratively in a JSON document. That's what CloudFormation is for those who are not familiar. It's a CloudFormation service that allows you to define your infrastructure in a JSON document, and then you just give it to Amazon and they build it. It's pretty much like, you give HTML to the browser and it knows what to render. You don't render this individual things yourself. It's quite powerful. So what we gain from it is we gained infrastructure, dependency management. CloudFormation handles all the underlying APIs, because handling APIs is another problem, and it's not trivial, handling different error conditions and all that. Supports rollbacks, so if it's kind of, I guess you can say it supports atomic operations, so if something fails, it goes back to the previous working state. It is fully reproducible, so each template, no matter how many times we build it, you're going to get the same results, and we can version it. What this actually means from a service is that I can build identical copies of my service on different environments, and that will give me the confidence that after I've run my test on my test environment or integration environment, when I push this to life, it will work. I get that confidence because they have the same shape. They might be different size infrastructure, but the shape is going to be exactly the same. And the other good thing is that I can version my infrastructure templates with my code, and this will give me full reproducibility of my full stack at any time. So starting from the infrastructure all the way up to CSS and JavaScript. And this changes a little bit the way I think of my service. My application is not just software anymore. It is the software and the infrastructure combined. It's a tiny change, but it's a big change in terms of how you think about it. So coming back to how we provision infrastructure. Obviously, we use CloudFormation, and we found that there's a nice categorization that you can apply to define different stacks for your application, so you don't define everything that your service needs in an environment in a single document, because that may be, first of all, quite big. And also, the different resources in there will have different management cycles. So your stateless infrastructure is usually the thing that runs your software and makes it accessible on the internet. Later on, we're going to look at a sample infrastructure for a service, and you'll see what that means. So it makes sense for that to be defined in a separate template, because that gets updated every time you deploy. This could be many, many times a day if you're doing it right. And then for your stateful infrastructure, depending on how things get managed, you can have multiple stacks that define your RDS databases, SQS queues, and all that. It makes it easier for managing it also lowers the risk for your data. And another thing that we use is, so CloudFormation uses JSON, and JSON is great for defining things. But another good thing about JSON is that it can actually generate it with code. And the good thing about code is it's concise, and I can do abstractions with it. So where we start to copy a lot of the same of CloudFormation templates around, we just abstract them with we use a Troposphere. There's different libraries there that are available in different languages to abstract CloudFormation, but one of them is that. So what this meant for us is that we as a central team, we provide a default template for people to create their services with. And instead of sending them a 500-600 lines of JSON, we just tell them, hey, import this, and run 3 lines of Python, and you're going to get your template. It's something to consider. So we looked at how we provision infrastructure. Now let's look at what we actually build, how we architect things. What are the considerations that we need to do? The architectural considerations, the main ones that you should make sure you've hit, and if you've done this, you've done a pretty good job, is resilience and security through different levels of isolation, high availability through multiple zones and regions, and scalability. And let's look at what these actually mean. The different levels of isolation are, one level is network and instance level, which means instances being isolated from each other and groups of instances being isolated from other groups of instances. And then there's another level which you may or may not hit depending on how big you are, how hungry your service is, which is, we call it resource isolation, which is the actual limits of your cloud provider on a given account. And no matter what you do, when you start using the cloud, find the API limits, because cloud is finite. It's not what they say. And obviously, once you know that, you make sure that critical services that consume a lot of resources don't share these limits. So let's quickly visualize this. So I have a group of instances that run software A, B, and C. First level of isolation is security groups around the instances, so that I make sure I specify what they can talk to and what can talk to them. And then subnets and access control lists around them to isolate groups of instances. Virtual private clouds to completely position them in different networks. And then if we put that in different accounts, well, you can consider that completely separate environments, because you've hit a pretty good level of isolation there, making sure that services in dev will never be able to impact in any way services in production. Scalability and resilience. Here's another thing. If you're not using auto-scaling groups, you're definitely doing it wrong. That is if you use AWS, of course. So auto-scaling groups are an abstraction that provides you an API for you to control groups of instances, making sure they're always there, and also providing you the capability to actually scale them up and down. And the benefits that you get is that auto-scaling groups ensure that your instances are always running. They can spread across different availability zones, which covers your, kind of that level of resilience. They make you a better engineer, and we'll see how. And they can actually deploy services. It's something that we use, and you'll see that as well. Forget about your instances. They're just the unit of your computational capability. If you're running services and you've given your servers names like Jon, Frida, Pete, and Yav, you're doing it wrong. Think of your auto-scaling group as the whole unit. Think of that as your service. Instances are just a detail. They specify, they're like a unit. They specify how big you are. And if you think of it that way, then you can handle in a much robust way failures, because machines inside can fail. But my auto-scaling group, I've told that you should maintain 10 instances or scale that way. It will do it. My service is my auto-scaling group, not the instances inside. And we ran something that the Netflix guys released in the open, which has been quite good for us, Chaos Monkey. And the important thing about Chaos Monkey is that it doesn't just kill instances. It helps you kill the machine from your mind. So you shouldn't say Chaos Monkey kills my instances. What you should say instead is Chaos Monkey impacts my capacity. It will run and it'll kill a couple of instances in my auto-scaling group, but that's fine. My auto-scaling group can handle that. It will either recover or it will continue to run my service. That obviously is possible only if you're running stateless services and put state in places where it actually belongs. Another good thing is the auto-scaling groups help us deploy our services. So after we bake an AMI using the bakery, we update the stack of the given service. And what this actually does is it updates the image property of the launch configuration of that auto-scaling group. For those of you that are not familiar with those terms, it's basically you've told the auto-scaling group, here's a new base image from which you should be creating instances. And then there's another thing that is attached to the auto-scaling group called an update policy, which you can tweak. And the update policy actually tells the auto-scaling group how it should handle the update, the rollout of those new machines. And the detail there that is important is that the update policy is something that you can tweak in the different environments to optimize for different things. On your test environments, obviously you want to optimize, or maybe you want to optimize for speed, which means that, and you don't necessarily care if your service has a bit of an interruption, which means what you can do is you can specify an update policy that says kill all machines at once and spin new ones in parallel at the same time. So the update is going to be a much quicker process. Whereas on live, you want to optimize for uptime. So you specify with the update policy that you want minimum number of services running, a batch size of machines to get updated, and then pause time to wait in between these cycles. And there's another thing which you should specify, which is you can tie that to the health check of the load balancer, which means that the auto-scaling group will wait for the load balancer to say, yes, that instance is up and running, but also the service in there has started and is responsive. So it will make sure that you'll never have downtime. So summarizing the infrastructure bit is use VPCs, subnets, and ACLs around those to isolate network access to your instances. Spread your infrastructure in different zones. Use multiple accounts where appropriate. So, for example, we use multiple accounts. Generally, our first approach is a team comes to us and says we want an AWS account, and we give them two, one for development things, one for production things. Obviously, if those teams actually have a specific service that requires a lot of resources, we can isolate that in a separate account as well. And run your services, the actual code, in auto-scaling groups. So let's have a look at our infrastructure in particular. First of all, the service-specific infrastructure, which teams are free to shape in any way and form. The general kind of pattern is you have, on one end, you have an auto-scaling group with security groups, IAM roles and policies, elastic load balancer, and a Route 53 record. In other words, the thing that runs the software and exposes it on the internet. And then, in addition to that, you can have different databases, queues, buckets, all the stateful resources that the application might need. And these all are organized in separate CloudFormation stacks. This template, the service template, actually fits into something else, what we call core infrastructure. So the core infrastructure is the thing that provides us with a frame upon which we build the different services. And it also provides the security and resilience through the levels of isolation that I mentioned before. So the core infrastructure for us is a virtual private cloud spread across the 3 availability zones in Europe. And it has 3 private and 3 public subnets inside. And when people build their service stacks, the auto-scaling group gets spread across the private subnets. So instances go into the private subnets, so they're isolated. And the load balancers get positioned in the public subnets. So they're the ones that talk to the internet, and they can only talk to the instances. So we provide this core infrastructure as a central team. And what people do is when they get set up with a new account, they build that core infrastructure. So this way we kind of get a nice consistency of the base infrastructure that is required for people to run their services. Now, what we end up with is a lot of accounts that people build their software in. So we allow developers to have full access to their instances, full SSH access all the way to production. And what this means is that we need to have something to kind of pull these isolated accounts back together to a single place, so we can provide them with an SSH entry point in the form of a Bastion service. And the Bastion services are like any other services. They get positioned in a separate account with their own VPC that gets peered. So with AWS, you can peer VPCs as long as they occupy different CIDR blocks. And this will make it possible for the Bastion instances to proxy through the corresponding instance that you require. So let's have a quick look at our pipeline again with kind of that knowledge in mind. People commit, goes in SVN or Git, Jenkins pulls it in, creates a clean chroot environment with mock, creates the RPM in that, posts it to our repository service, which makes it available as a YAM repository. And then Jenkins notifies Cosmos with the release metadata for that particular release. And then developers kick off a deployment on test, either programmatically or with a push of a button. That goes to the bakery. The bakery does the 2-step snapshot thing, returns an AMI, and that gets deployed to their test service, updating their infrastructure on test, and that updates the auto-scaling group. Then they kick off their tests. Tests show green, hopefully. And after they show green, they can actually promote that service to live. And again, that happens via the bakery, but we go from the already recorded software snapshot, ensuring that we deploy the same binary with different configuration. That's kind of it. So, all right, trying to figure out how to tie this back. What this means is that we've given quite a lot of freedom to people to solve the problems to the most appropriate way that they think exists. The spinning up infrastructure, choosing a language for solving a problem, but then management deployment cycles. It's something that's very important as well. The flip side of that is another good thing is that they can actually measure how much they cost, because that's the beauty of the cloud. It can give you a precise number of how much your service costs when it runs, and then you can look at other things and measure whether you need to change things. The flip side of that is that we require more responsibility from people. What this also means is that the separation that we had between operations and devs can no longer exist, because infrastructure is moved closer to the development team, which means that's where operations need to go as well. Because the thing is, everyone has knowledge, and everyone has good knowledge. So the thing is, the trick is to distribute these people closer together in smaller groups so they can work more effectively and, start acting as a team. I think that's a positive note to end with. We're on GitHub. Not all the things that I showed you there. In the next coming months, we will be open sourcing a lot of the things that are in this pipeline. So if you're interested, follow us. It's exciting times. We think of extending our bakery service to use Docker, right? Docker's all the rage. But the reason why we want to do that is, I guess, we want to give people the tools that they need for them to produce the artifacts that they think they need, and then try to make sense of them all together. With the community, of course, trying to kind of figure out how that deployment model is going to mature. By the way, I bring guests. They're actually sitting over here. It's Rich Close and Olivier. They're software engineers from our team. And the thing is, if you see those faces, they know at least as much as I know. So ask them all the questions that you have in mind. If you can't ask me, they're generally friendly and they have thick skin, so they can handle very hard questions. Anyway, questions from you? Yes. Yes, go for it. Well, the tool is very simple. It's called a phone. So each of the teams kind of go on a rotating quota, and people are on call, the actual developers. So if something goes wrong on live, you contact directly the developer, and he should be able to solve the problem without esoteric language. And I guess the way you measure that, it's actually probably easier than what you would do if you had this layered separation of 24/7 teams, monitoring teams, operations, and then developers, because you kind of lose information along the way. When you've actually put it down to the team, it's much easier to monitor. I mean, you can monitor their success rate. The thing is that the funny thing is that actually, once you've given them the phone, they actually think twice before they do stuff, right? So you kind of naturally get a lot more responsibility out of people, because they don't want to get called like 4 a.m. to fix stuff. Yes?
Are you using pull requests as part of the cycle, or do you automatically do any code change a branch directly to the branch and then it goes?
Well, that's again down to the team. So each team defines their own way of working. Generally, my team we just work off trunk. So we want to resolve problems as quickly as possible and as in smaller batches as possible. So branching off and doing all that stuff is something that you could do, but I find the easier thing is to just push it one place and continue to deploy to spot problems as people work. Yes?
With the service skeleton that you provide, do you also provide the logging and metrics collection for the entire suite of different products and their respective services, or is that only for the services?
So what we do provide is in the core infrastructure template, so the underlying one, we provide configuration that collects all the logs from CloudTrail. CloudTrail is the thing that exposes all the activity in your account, like regardless of the API. So we provide the configuration that is needed to take those logs and shove them in a centralized place in another account. So we give full visibility of what's going on in all accounts. But then for application-specific metrics, it's really down to the team what things they actually push in logs and how they monitor that. Because they're the ones that look at it, right? You had a question here?
You're very significant on AWS as a service. Does it worry you that you're so tied into the proprietary systems and software? Is it taking risks to you as an organisation?
I don't see it as a locking because all those mechanisms that I described, that kind of general principles that you can apply elsewhere. Yes, at the end you do end up with an Amazon machine image, but with the same set of information you can easily create, for example, a Docker container, and you could be deploying somewhere else. The infrastructure bit, yes, it's all Amazon services, but I think the thinking there is you either take full advantage of the full plethora of services that a cloud provider gives you, or you kind of work with the common limited set of all the other ones. That's kind of the approach. But having said that, we're not just tied to Amazon. We're on the lookout. We're quite interested in what people do in that space. Yes. One more question. Yes. Oh, the service level dependency. Well, this one is hard, and I guess I think that's more of a social problem. I might be wrong, because the idea that you deploy continuously to test means that you're constantly integrating with the services that you're depending on. So if there are any problems, you spot them there. How do you actually express service dependencies with technology? I don't have an easy question for that, and I guess we don't really do it. We just let it down to teams to work that out. I will be available for office hours right after this if you guys want to speak with me about things, and these guys as well. Thank you.